So it does some processing. So maybe sometime after 1 hour also, sometime after half an hour also. I think it is getting recorded. Yeah. Okay, I'm audible properly, no issues, no? So if sometime you find there's a delay between the voice and the text are not going simultaneously, then you tell me. Okay. So you think of vector as a new kind of or new species in mass. So one thing we know already, like scalars, like suppose if I say temperature is this much, like 20 degrees Celsius, so it is 20 degrees Celsius. There is no sense of direction, something like that is in there. So suppose if I ask you how to reach Gilpop from here, can't tell me that you go 10 kilometers just like that. You have to mention that how to cover that 10 kilometers, like in what direction and all. So there are there is some species in mass, the one which comes with two information. One is how much we have to do, and another is in which way we have to do. So how much we have to do? Suppose if I ask you travel 10 kilometers towards east. So how much I am doing is 10 kilometers. And which way I am doing is eastward. That will be called as directions. So a quantity to be called as vectors, the necessary condition is means necessary condition means this must be there, but that is not enough. But if this is not there, then guaranteed it is not a vector. So necessary condition is it must have magnitude, means how much to be done. And it should have direction, means which way that thing must be done. But suppose something having direction is necessary but not sufficient. Correct? It is necessary to pass 12th to get into JE, but it is not sufficient. No? But if necessary not happening, then there's no need to check the sufficient condition. So something not having direction is straight away not a vector. Like temperature has got nothing like direction we can think of. So not a vector is straight away, it's going to be a scalar. But something having direction may be a vector, may not be a vector. How to judge that? That is the sufficient condition. Sufficient condition is like it should follow vector algebra. Then if you'll ask me what is vector algebra, this chapter is all about vector algebra. It follows, can you sit here, conclusion, follows, or maybe which way is comfortable for you? Which way comfortable, no? You come here only, because if you put somewhere your legs also. Don't worry, you come in camera, so what? It follows vector algebra. I'll give some examples, but that does not mean that there are so many examples. There are just few only. One example is of electric current. See, just because someone having hand and leg is not going to be called as human being. No? Anything extra than hand and legs are supposed to be correct. Because some people may not have hand and legs, then still we can call them as human being, correct? So something to be called as a vector, just direction not enough. It should follow the vector algebra, like it is like characteristics of some quantity in a mass. No? So just because something came from Mars looking like human being having two hands and two legs, and if you will give him Pepsi to drink, he will die, no? Because he looks like human being, but he is not having the characteristics of human being. His metabolism might be different, might be CO2 poisonous for him, who knows, correct? So new species will have new characteristics. So characteristics of a new species in mass has got a different name, algebra. So electric current has both the direction and magnitude. You're comfortable now? Or maybe I'll sit here, then you can sit. That will be better. Has both direction and magnitude. Is still not a vector. The reason is that we are going to discuss very soon also. The reason is it do not follows something that we are going to see very soon. Triangle law of vector addition. Another example is of something called as angular displacement. So whenever we'll be checking out this angular displacement guide there, I will be discussing in detail just for nice notes to write it down. Angular displacement, see, when finite, by that I mean when it is not infinitesimally small. So what happens when angular displacement is finite in such situation, even though it is having direction, but still it is not a vector. But when it is finite, when it is very, very tiny, infinitesimally small kind of tiny, then totally it is a vector. But when it is finite, something that you can observe or check it out with naked eyes, then in such situation it is not a vector, even though it has direction. So when finite, it is not a vector, even though it has direction and obviously it has magnitude. The reason is it do not follows something we call it as commutative nature of vector addition. Do not follows commutative nature of vector addition. Okay. So you can take a screenshot also. I'm going to share this PDF also, but still, if you want to write notes, you can write notes also. If it is pure physics thing, then you must be writing notes essentially. But maybe we are doing like some sort of math thing. So all of these things are going to become your muscle memory very soon. So it's not a problem. The beginning will feel weird and maybe it's confusing also, but with time it's going to become like so easy that even if with half brain working, you could handle all these things without any issue. Okay. So what is triangle law of vector addition? Or what is that commutative nature of vector addition? All we are going to see very soon in this chapter only. Just for nice notes, you write it down here. But you will be understanding it what they are later on. Okay, I can take a new page now. Okay, I can take a new page. So like so small page I have. It's not like big like board. So next thing is, suppose if I have a vector quantity by which, or suppose we have something like we travel a distance of 10 kilometers towards east. And that is called as vector A, suppose. So to tell this mathematical quantity A is a vector, we use a symbol arrow over its head. So suppose if I write this arrow over the head, but with modulus or this bracket looking thing, which is modulus, means I am talking about the magnitude of the vector. And what it is? 10 kilometers. And what is the direction it has? Eastward. No? So whenever the word vector comes, it comes attached with two information. One is the direction, other is the magnitude. So how to represent the vector graphically? Suppose if I have to represent that above vector A graphically, so what really it is, 10 kilometers is having the magnitude or length. So it's not like, and to represent a vector graphically, what we do, we draw an arrow where the length of the arrow is going to represent magnitude. So do you think if I say length of the arrow represents magnitude, so what will be the length of the arrow that you will draw? 10 kilometers. How come you will draw 10 kilometers? Even you can draw, but we will not draw. So what we will do, we will take some scale. Like if I ask you to draw the map of India, not like you will ask me a page as big as country India, no? So for that you will take some scale that this many kilometers on the ground is this many centimeters on the map. Same way with taking some scale, you will draw an arrow. Maybe if I take 1 centimeter is equal to 1 kilometers, and then I will draw an arrow of 10 centimeters, even though we are drawing 10, but what really in our head we understand it is we're drawing something of 10 centimeters, but in our head, what really we understand it is 10 kilometers. So the length of the arrow is going to represent the magnitude. And whichever way the arrow is pointed along, that will be telling us the direction. So we will draw an arrow which will be pointing towards eastward direction to represent this vector A. So as you can tell, this head of the arrow, this is the head of that arrow, and this is the tail of the arrow. So the length of the arrow is not magnitude, it represents the magnitude. No? So we draw the map of India, it's not India, it represents India. No? Okay. Now, if I say two vectors are equal, then what really the condition must be? So vector comes with two data, direction and magnitude. So if both the things are equal, then we will say equal. So if vectors are equal, so two vectors will be said equal when the magnitude and direction both are same. No? Suppose if I use the word velocity vector, suppose if a car is traveling with 10 meters per second towards east. So the speed of the car is 10, which is the magnitude of the velocity vector. But the velocity vector is going to be a vector whose direction will be eastward. So suppose if I tell you two cars, one car, a car in Chennai going towards east with 10 meters per second. And another car maybe in Pakistan, like dangerous place, going towards east only with 10 meters per second. So tell me if I say the velocity vector of both the cars are equal or not, even though they are not same car, they are not even in the same country, man. Still the velocity vector of both the cars are same, is it not? Next example I give, like suppose, I hope you got the example. No, so wherever they are doesn't matter. If and whosoever's velocity they are doesn't matter. No, what matters? Length equal, yes. Direction equal, yes. So nothing said about whose velocity it should be. No, in the equality condition. It's like fighting a case in a court. We are stickler to the rules. Direction told same, magnitude told same. Third thing we will not be thinking. These two things same, so same. So sometimes physics will feel like following rules, man. One who can follow rules more properly It's like that actually. Suppose daily you go to Tambram from Porur and you have to travel like maybe 10 kilometers this side. Yellow color not visible. 10 kilometers this side. So one day this road was blocked. So what you did, you traveled on a road parallel to it and you have traveled 10 kilometers on this. So tell me, so this blue arrow and this black arrow are of equal vectors or not? Because where I am drawing those arrows, you don't get entangled into that fact. You just think of arrow is in same direction. Yes, arrow is of same length. Yes. So vectors are equal. No. So I'll write a statement. Tell me correct or not. Shifting a vector parallel to itself, the vector remains unchanged. Because if I have a vector, this one. Now what I will do, I will draw this arrow of this vector somewhere at some other location. As long as that arrow is of same length, as long as the arrow is pointing in the same direction. So direction not changing, length not changing. So what really we can say, vector not changing. So shifting a vector parallel to itself. So this I call it as vector A. Then this is also can be used to represent A. This can be also used to represent A. No? So shifting a vector parallel to itself, the vector remains unchanged. Okay. I hope this thing is clear now. So equal vectors, all of you got it, no? I did not like over explaining. And I hope this example is not confusing you. Instead, is giving clarity, no? Okay, then copy this thing. Once done copying, tell me, I'll take a new page. No, it may be difficult for you to sit, man. Don't bring those like cut C and those things. Something giving you difficulty in study, tell it straight away. If so this might be this way is more comfortable. No, you can put your lesson, you can write on table. Now you're seeing video also. It will not be awkward for me, it will be awkward for you also. I take a new page. The next thing is how to find angle between two vectors. So thing is, few tasks will be the one where things are supposed to be done in some order, no? But few tasks will be where you do things in whatever order. It's not going to be of any matter. Like for example, to operate kidney, you should before opening kidney, you should open the stomach, then only you can reach kidney. No? Directly kidney, how you reach? Not a good example, but maybe you get it. So few tasks are something where order is important. So here also it's like that. So suppose if I ask you find angle between B slash W means between vector A and B. Or if I ask you find angle between vector B and A, both are not same. So that is not same as angle between like how to reach Delhi from Chennai or how to reach Chennai from Delhi. It looks like same, but not same. No? Same sort of thing here we have. So angle between vector A and B and angle between vector B and A, both are not same. So finding angle between two vectors, order in which they are asking us is important. So whenever order is important, we say it is non-commutative in nature. Like A will not, A cannot be take, A cannot take the position of B and B cannot take the position of A. So angle between A and B first. So in the ascending order, A is appearing first. Now if you find angle between B and A, then in the ascending order, B is appearing first. So here order is important. In such case, we call it as it is non-commutative in nature. Okay, next thing is, in order to report angle between two vectors, some rules are there. What is that? The vector should be given to us in this, so like that point even, vectors must be given in this arrangement in which the tails of the vectors are together. No? Suppose this is vector A and that is vector B. So either they must be given in this arrangement in which tails are together, or they must be given in this arrangement. You see, one is A, other is B, and their heads are together. So there's a name for this arrangement but for doing physics, you don't have to know the name, but still I'll write down. So this arrangement is called as co-initial arrangement because their starting point or initial points are at common place. So for common shortcut word may be co, so co-initial. And here they are terminating at one point or at one place. So their terminating points are like common. So there comes the name coterminous arrangement. Or we can use that layman's word also. It's 18 hours. As we have to solve objective question that it is not physics on. Like tails together arrangement or heads together arrangement. So then the question may come to your head that maybe every time a vector is not given to us in this or this arrangement, then what to do? So maybe I'll draw something for that also. Suppose if I draw, this is vector A, maybe I will draw blue color for it. Yellow not visible, pink looks nice also. This is vector B. Now, if I ask you this blue arrow vector A and the pink or red one, yeah, this bright red or pink, whatever it is, this blue arrow, this red arrow B, what kind of arrangement they are in, whatever it is not coterminous or co-initial. So if you come across such situation when the vectors are not in co-initial or co-terminus arrangement, then what you do, I write that thing. If not given in co-initial or co-terminus arrangement, then shift one of the vector parallel to itself, because we know on shifting a vector parallel to itself, the vector will not be changing. And I want them to be in a certain way. So to bring them in that way, we will shift one of the vector parallel to itself in order to bring them in co-initial or co-terminus arrangement. So we will see what to do in such case. First, we will see in case if they are given to us in this or this arrangement, whichever arrangement they are given, either co-initial, co-terminus, anyone you can use, both will give us same answer. Some people have shown movement. Maybe. You copy this thing. One, two, three, four, five, 6, 7, 8, 9, 10, 13, 14, 15, 16. Yes, I forgot the shortcut key for screenshot. Let me take it here. I'll take a new page. See, once they are given in co-initial or co-terminus arrangement, what to do, we will see that thing. Suppose this is our vector A and this is our vector B. And they are already in one of the arrangement I want them to be in. That is co-initial. And suppose if it is asked, find angle between A and B. So this is the symbol for the angle B plus W means between A and B. So if I ask you find angle between A and B, tell me in the asking order, which thing is appearing first? In asking order, A is appearing first. No? Give me 1 second. It is a lag. Hello. Yeah.
Sir, I couldn't hear you, sir.
Now I'm audible. Right?
Yes, sir.
No, yeah, just a moment. Now I'm audible. Yeah. So see, if I have to find the angle between A and B, then you must first check what is being asked in the asking order, which comes first. Angle between A and B. So in the asking order, A is appearing first. Okay? Because here the order is important. Now you try to do one thing. So this is the red arrow of A and this is the blue arrow of B. So you think of rotating this red arrow of A about its tail so as to bring it at the place of B. So one way you can rotate him like through this way. Just a second. One way you can rotate him like this way, correct? Or other way you can rotate him like opposite way, no? You can't rotate him like that. One way you can rotate A about its tail to bring it at the place of B is to go via this red arrow. Other way is to go via this black arrow, correct? Among these two, which is the smaller one? The red one. So that will be the angle between A and B. So maybe I'll write that thing in words also. Since A appears first, you start from A to go towards B. THRU, our spelling through the smaller angle between them is the symbol for angle. B slash W means between them. So whatever that a smaller angle between them is, that is the angle between A and B. So in this current figure, the smaller the one is this red arrow. No? So this red arrow is going to be the angle between A and B. And suppose that angle I call it as theta. So just theta telling theta not enough, man. I also have to mention which way to rotate. Okay, suppose you're doing some like real fighting thing and enemy is 90 degree from you and you have to fire towards that enemy. Your friend tells you turn 90 degree. Then you'll ask, no, which side 90 degree, man? If he tells wrong side, your enemy will be at the back side of you. Correct. So I also have to mention which way that theta is, clockwise or anti-clockwise. So and again I can say anti-clockwise maybe or clockwise maybe, but we want to use less number of words again. So if I say plus 30, it means anti-clockwise 30. If I say minus 30, it means clockwise 30. So anti-clockwise will be reported as positive. That is the convention we have. And clockwise angles are reported as negative. So in this case, the angle that is between A and B, whatever it is theta anti-clockwise. So I will report the answer as plus theta. Okay. Now, here only you will see, if I ask you find the angle between B and A, same are the vectors, okay? Same arrows, everything same. This is A and this is B. Now, if I ask you determine the angle between B and A, then you will start from B and then you will go towards A through the smaller angle between them. And that will be same as this angle, as you can tell. But it is in opposite sense now. So in here, the angle that is between B and A is going to be given by this red arrow, and that is theta. But what theta? Theta clockwise. So I will be reporting it as minus theta. So you can see if the angle between A and B is theta, then the angle between B and A will be minus theta. So the angle between A and B is not same as angle between B and A, because if I ask angle between A and B, what is the physical thing maybe I might be asking you is to rotate A. So bring it at the place of B, but you have to do rotation through the smaller angle because we want to use less. So you will be rotating in through maybe 60 degrees anti-clockwise. But if I ask you find angle between B and A, then maybe I might be asking you to find by what amount B will be turned through so that it comes to the place of A and we must use least amount of effort. Then we must be rotating B through an angle of 60 degrees, but it will be in clockwise sense. No? So maybe I'll write one point. If angle between, if I'm using the word if angle between A and B is theta, then angle between B and A will be equal to minus theta. This thing is clear, how to find angle between two vectors. Once they are already given in coterminus or co-initial position. So someone joined right now, no? You're able to follow these things? Because you might be knowing slightly of vectors before also maybe. Anyhow, I will be sharing the recorded session also by tomorrow maximum. Okay, copy this thing. Any doubt you can ask me on. Anyone having any doubt? Having doubt is good. Okay. Not asking the doubt is very, very bad and dangerous also. Okay. Vimal, you're joining now and how you will understand. So, Vimal, do you know what is vectors slightly from before? Maybe fine. When I'm asking, try to reply, otherwise it feels boring for me. Okay, I can take a new page.
Why we not considering the for be
Then because that is how we are supposed to define the angle. It's not about like why, it's about once I have decided, okay, we are going to have this convention. Convention maybe it's like why bucket is called bucket. You can't, like bucket is called bucket because we decided that this thing will be called as bucket. So we decided that, okay, this way we are going to report the angles. Otherwise, it will get confusing. Someone will report this black one, someone will report this red one. So everyone must come to a common platform for the reporting purpose to avoid confusion. So then if I sit and think of what way we must from today onwards will be calling angle between two vectors. So you only will think, okay, I have to use this or this to be called as angle between them. Which one you will think? Smaller one. Because if literally A has to travel to the place of B, naturally what he will do? He will take the smaller path. That will be more natural thing to do. So we defined that smaller one will be called as angle between A and B. So by telling that I can even do literal rotation of the arrow of A by that much amount, I will come to the place of B. Correct? If angle between A and B is 60 degree anti-clockwise. So rotate the arrow of A through 60 degree anti-clockwise. You will be in the same direction as B for the minus. But no, it is why it is like that. So it's like we decided everyone must move on the left side of the road because to avoid accident. If everyone decided in the beginning only that we'll move on the right side of the road, then right side of the road. Convention, no? For convenience. That's why that may be the root word of convention, maybe not for convenience. Maybe. But every time vectors may not be given to us in either of these. Those who have joined now, just I'll try to tell minimum so that you can understand. So we use arrows to represent vectors. Vectors are quantities which has direction and magnitude. So the length will represent the magnitude, the way the arrow is pointed towards will be telling us the direction. So if magnitude and direction same, vectors will be same. So if I shift the arrow of the vector from one place to other place, but we are shifting it parallel to itself, it will not change the direction, it will not change the magnitude. So vector will not be changed. So shifting a vector parallel to itself, the vector will remain unchanged. How to find angle between two vectors? They must be given to us in this arrangement in which tails are together, or they must be given to us in this arrangement in which heads are together. So if given to us in either this or this, and if I ask you find angle between A and B, then finding angle between A and B is different from finding angle between B and A, as different as going from Delhi to Chennai or Chennai to Delhi. So in asking order A appears first, so we will think of rotating A so that to bring it at the place of B. Suppose if vectors are given to us in together arrangement, then I will rotate the arrow A around its tail maybe so as to bring it at the place of B. So two ways I can rotate through this bigger one, this is black one, or through this smaller one, the red one. So we like to do less work, so we will be rotating it through the smaller one. That smaller one will be the angle between A and B. So in here, suppose that angle came 60 degrees, but that is not enough. I have to report even the sense of that angle, which is anti-clockwise. So I can write it is 60-degree anti-clockwise, or maybe I will use this thing plus 60, because anti-clockwise angles will be reported positive and clockwise will be reported as negative. So if I ask you find angle between B and A, then you think of rotating B around its tail so as to bring it at the place of B. A, sorry. So we are asking you find the angle between B and A. So B is appearing first in the asking order. Then you start from B and go towards A. So two choice you have. You can go through this black arrow path or you can go through this red arrow path. But the smaller one will be selected. So if this one came 60-degree anti-clockwise, you will see this will be 60 in magnitude, in amount. But the way we have to rotate B is exactly opposite to the way we will rotate A. No? So if angle between A and B, if it is given as theta, then the angle between B and A will not be theta, it will be minus theta. So angle between A and B is not same as angle between B and A, as you can tell. Now next thing is 180 degrees, then again, in that case, what 180 degrees, anti-clockwise or clockwise, both will be same. So that is the case when same, but not every time. Okay. There also sense will matter, no?
So if the angle between both the vectors are is one,
In such case, I can it's totally fine. Suppose if angle is 0, then what is the
side should
angle
be
between A and B? It's like they are anti-parallel, no? So parallel, anti-parallel, different thing. It's like not having any angle sort of thing, no? If
uh,
angle between A and B is 0, then what is the angle between B and A? Also 0. It's that kind of thing. But no? Okay. So suppose if this is A and B, 180 degrees if it is, angle between A and B, I can report this also, because both paths are identical, so both answers are correct for the binding. But if both are same, then still I will use the anti-clockwise one. Now suppose if I give you this is our vector A, this is of our vector B. Now right now, maybe I will use different arrow color for B. Green visible, no? Well, this green one is the arrow of B, and this blue one is the arrow of A. Now, right now, they are not in the arrangement I want them to be in. So we will bring them in the arrangement, either co-initial, the tails together, or co-terminus, the heads together arrangement, by shifting one of the vector parallel to itself. So one thing I can do is I can shift the arrow of A so that wherever lies the tail of the arrow of B, there I am going to place the tail of the arrow of A. So see, I'm drawing another arrow here, which is parallel to the arrow of A, and that is of same length as the arrow of A. So now, if I use the blue arrow of A to do some calculation where A is involved, or I use the black arrow of A to do some calculation where A is involved, both are correct, no? Because both are same only. But for finding the angle, there's certain condition. That vector should be in tail head, the vector should be in co-initial arrangement or tails together, or co-terminus arrangement, that is heads together. Now, you check out the green arrow B and black arrow A. They are in the arrangement, the one I want them to be in, that is co-initial. Once they are in that arrangement, then we do the same thing. We start from A, we go towards B through the smaller angle between them. No? Whatever the smaller angle that is between them, that is the angle between them. So that came, suppose theta, which by looking at it, you can tell it is anti-clockwise. But suppose you don't want to bring them in co-initial arrangement, you want them to be in co-terminus arrangement. So what we can do instead is, can shift the arrow B maybe parallel to itself also. Whatever is comfortable to you, you do that. I will shift the arrow B parallel to itself, drawing it at the place where lies the head of the arrow. Okay. So what I have done, this red arrow B is an arrow which is shifted parallel to B, and its length same as the green arrow B. So whether I use green arrow B to do something where B is involved, or whether I use red arrow B, it's not going to be of any problem. Both are same. Because shifting a vector parallel to itself, the vector doesn't change. Now tell me, now I'm going to use the blue arrow of A and the red arrow of B to find the angle between A and B. And now blue arrow of A and the red arrow of B are in what kind of arrangement? Co-terminus. No? The tip of the arrows or head of the arrows are together. Now what is the algorithm is? I'm asking you find angle between A and B. So you will be starting from A and you will be going towards the B. Then the angle that is between them is this black one theta. Suppose if it is given, this much angle is 120 degrees. I'll use different color. This red part is suppose 120 given. And if I ask you what is the angle between A and B, I can say using this blue theta, theta is 60 degrees. And what is the sense of the theta is? Anti-clockwise. Now tell me this blue A arrow and this black arrow of A, both are on the same line. This green arrow B and the red arrow B, both are on the same line. So this blue theta and this black theta are vertically opposite angles. So they are equal in magnitude, that is obvious. But can you see whether they are equal in direction or sense also or not? What is the orientation or sense of the arrow blue theta is? Anti-clockwise. What is this one? Also anti-clockwise. Doesn't feel like that maybe sometime, but it is also anti-clockwise or not. So this is also same only. This is also 60 degrees anti-clockwise. So whether you want them to be in co-initial, you use co-initial if that is comfortable thing for you, or you want them to be in coterminous, that too is fine. I hope all of you got it now how to find angle between two vectors. No issues. Okay. Maybe do one like very simple question. So this beginner box question. 3 you try on your own today, 4th one you try now. So we have one force vector, another force vector. Like this it is drawn. And this angle is 60. And they're asking us find the angle between A and B. To this question. Find angle between vector A and B. So try to do it in your head only. Shift the arrow of A parallel to itself. 120 degree what? 120 degree what? Clockwise, anti-clockwise, that too you have to tell now. Because options contains minus 120, plus 120, and 2 more. So we will shift the arrow of A parallel to itself. Suppose here. So if I shift the arrow of A parallel to itself, this is the arrow of A, which I'm drawing it by dotted blue line. That is of same length as the arrow of original A and in the same direction as the original A. And this dotted arrow can be also used to represent A. So since we have to find angle between A and B, A is appearing first. Now what we will do in our head, we will delete this old arrow of A if that is making you uncomfortable, or maybe you redraw the figure again, deleting the old arrow of A. This is the arrow of A that is going to be used now, and this is the original arrow of B. So we will start from A and then we will go towards B. The two choice we have, we can go through this blue path or we can go through this green path. And you can tell which is more, blue one is less. So that will be reported as the angle. And that is 120 degree, you can tell, and the sense of that one is clockwise. So angle between them will be minus 120 degrees will be reported. Or if you don't want to use sign, you have to type 120 degree clockwise. Okay, I hope this is clear over this thing so that I can take a new page. I'm not doing a bad thing taking online class now. All of you are able to understand now. Why to waste this golden time of summer holidays to complete more syllabus, get ahead of the other people? No? Because many people I know, they have completed all 11, 12 syllabus by this time, man. But that does not mean that you are not in competition. Once you complete the syllabus properly, maybe even 3 months before the exam, that is also enough to get good rank. It's not bodybuilding that you have to make muscles here. It requires more time. Okay, I'll take a new page. Next thing that we are going to talk about is addition of 2 or more vectors. So vector is a new species in maths. So adding things can mean different things than whatever adding means in case of scalars. Adding 2 plus 3 rupees gives us 5 rupees. We understand what addition means. So new kind of species will have new kind of metabolism. For new species, eating will mean different thing, and how they eat might be also different, no? And what they eat might be different also. The same way here, addition means something might be different, and how to add is also different. So adding 2 or more vector, there's another name that is also called as finding the resultant of 2 or more vectors. adding two or more vectors. Or finding, it is also called as finding the resultant of two or more vectors. Now, tell me, in 9, 10 classes, you must have done finding equivalent resistance or not. So you will be told, you will be given some bunch of resistors depending upon what kind of combination they are in. Like parallel series, you will be finding the equivalent resistance. But what is that equivalent resistance means? It means instead of using those bunch of resistors, you just use one, that is equivalent resistance, the one which will bring same effect in the circuit. No? The same thing sort of it means here also. Suppose if I'm adding two or more vectors, maybe I'm adding A, B, and C like that, so many vectors. And I'm writing it equal to something. So if I add 2, 3, 4 vectors, what we get maybe vectors only. No? If I add 2 cows and 3 cows, it will not become like 5 buffalo. No? LHS, if it is something, then RHS must be same thing. Suppose I write it down as R. So adding two or more vectors, we must be seeing some vector only. That is like obvious kind of guess. But what is the significance of that R is? So adding two or more vectors means finding, but don't write this definition in your mass vector exam and you might get 0. These are definitions for understanding purpose more than anything. Maybe could be useful sometime also. Adding two or more vectors means finding a single vector that brings same effect as the vectors which are added when they act together. Suppose if I'm adding three vectors only, A, B, and C. When adding A and B and C, what really we look for is finding one single vector R, the one which can do same job as A and B and C were doing together. So it's like you fire A, B, C, and you hire one guy R, job done will be same. I hope that point is clear to everyone. What really we look for when we try to find sum of few vectors, we try to find one single vector, the one which is going to bring same outcome as whatever the vectors that we are adding, they bring, but when they add together. So if I'm finding sum of three vectors A, B, and C, it means I'm finding one single vector R, the one which will bring same outcome, whatever A, B, and C were bringing together. Correct. So if I add three force vector, what we get? One single force vector, the one which will bring same outcome. Like maybe simple example one I can give. Suppose if I have a block kept on a surface and we are applying two forces, one of 5 Newton, other of 10 Newton. So for this, you don't need to know vectors. If I ask you what single force I can apply instead of these two, which are of 5 and 10, so that the effect on the block is same, you will say, maybe I'll take something like 7 Newton so that they look different. So if I apply one force of 7 Newton and one more force of 10 Newton, both in the same direction. So they are like two vectors, maybe you call it as A and B. So what single vector, force vector I can have, the one which will bring same outcome will be what? 10 plus 7 will be 17 Newton. No? Correct. So what I will say, the resultant of this and this is this guy. One more example I can give. Suppose on the same block, I am going to apply a force of 10 Newton this side, and I apply a force of 7 Newton this side. So what single force vector I can have acting on him, the one which will bring same outcome will be 3 Newton this side. This side, left side or right side? Right side only. So suppose this vector is A and this vector is B. So the resultant of this will be this vector. Now if I ask you, tell me what is this R vector is. So how many things you have to tell me? Two things, no? That this vector is of 3 Newton and it is acting in this leftward direction, no? Correct. So I have to report direction and the length. Because if I don't know a vector, really we don't know two things, which are the length and the direction of the vector, no? Correct. This is one example I can give. A better one I'm going to give now. I hope this much is clear, whatever is on the screen, no? What is the meaning of adding two or more vectors? That is clear now. Right. Now suppose you went for jogging from your home and you want to tell exactly how you have done the jogging, how much, which way, where you have reached, things like that. So whenever we have to measure lengths, we have to have a reference from which we measure things. No? If you have to measure 2 centimeters, we have a 0 on the ruler, the reference. And we are going for jogging, not like flying like Iron Man. No? So only two directions, or it is going to be something in 2D. Height will not change, some distance you will be traveling in 2D on ground only. No? Correct. So X and Y axis, maybe this is our eastward direction. This is northern direction. And the point from where you started moving your home, I will take it as origin. Or again, eastward, northern, like boring things. So we'll say this is X direction, suppose. This is Y direction. Now what you have done is, suppose you have done traveling 3 kilometers along X direction. And that is vector A. Suppose vector A is traveling 3 kilometers along X direction. So we have drawn an arrow of not 3 kilometers, maybe 3 centimeters, where 1 centimeter will be representing 1 kilometer. But in our head, we think it is 3 kilometers. No? And for representing A, I am using the arrow PQ. What I am trying to tell, in order to do that, you will be using triangle law of vector addition that you don't know. Right now, we don't know what is triangle law of vector addition. And then you will realize that you have applied triangle law of vector addition without knowing you are applying triangle law of vector addition. It's so natural thing to apply. Because if you'll ask me the proof, then I will take this example. Next, what we do is we travel maybe 3 kilometers. Not 3, maybe next we will travel 4 kilometers along Y direction or northern direction, and that is given by vector B. So by doing vector B means you have traveled 4 kilometers along northern direction or plus Y direction. And to represent vector B, we are going to use the QR arrow. Okay, but maybe I will use some different names. Because R I'm using for resultant, no? So for representing A, I will use OP arrow segment. To represent the vector B, I'm going to use PQ arrow segment. Now tell me, what is the net effect of doing A and B back to back is?
Reaching point.
Reaching the point Q from O. So tell me what single thing I must do so as to have same effect as the effect due to doing A and B both is to travel OQ or is to do OQ or not, correct? So whether I do OP and PQ, see I'm using the word and I'm stressing on it even. So I'm doing A and B. Instead of that, what single thing I must do to get same job done is to do OQ or not? Now if I ask you, tell me about that vector OQ. Then for that you have to tell the length of the arrow OQ. And to find the length of the arrow OQ, it's not like you will do some big math thing, you will use Pythagoras. But whenever I use the word Pythagoras now, I feel bad because it was invented in India. Guys took it and named it as their own only. Yeah, correct. So that is 5 km. So now tell me, suppose you don't know Pythagoras, then what you will do? Or you don't know maths, then what you will do? Literally, you will take some ruler and you will measure OQ, and straight away. And you took things according to the scale. You have drawn OP of whatever the method, that doesn't matter. Main thing to understand is OQ is the one thing that will be done instead of A and B both to get same outcome. Now to report that vector OQ, I have to find the length of the segment OQ. For that, maybe literally I will measure OQ using a fully accurate and precise ruler. So if OP I have drawn 3 centimeters, this one 4, that will come 5 centimeters. And then we know, okay, 1 centimeter is equal to 1 kilometer. So I will know, okay, OQ, the vector which will replace A and B both, will be of length 5 kilometers. So the length of the arrow OQ will be 5 kilometers. We have reported the direct magnitude, but how to report the direction? So suppose if I tell this angle, how we find that angle? Because we know trigonometry. And this is a special one that I told you, remember? I told you to remember this triangle. And there is approximate angle, but in physics, if that angle comes, you will use this 3, 4, 5. If the triangle is like this, then this angle is 53 degrees. So suppose if I ask you to report this angle theta, this angle 53 degrees to report the direction, is it not enough? Enough. No? I will tell it is making 53 degrees from eastward direction or 53 degrees north of east, no? Or I can say 53 degrees due north of east. Okay. So I'll write down. So what we are adding here is A and vector B. So adding A and B is same as adding OP and PQ. And through some logic, we have understood that doing whether I do OP and PQ, instead of that, I can do one single thing, which is OQ. So I will say OQ is the resultant of OP and PQ. So I'll say OQ is the resultant of A and B. I hope you're getting this point now. Is the resultant of vector A and B. Now to report his magnitude, we'll be finding out its length and doing some math thing, we found out it is 5 kilometers. And to report its direction, suppose if I ask you add vector A and B. When you can add A and B vector, when you know what vectors A and B are. Means A and B are not unknown vectors, though those are the vectors that you know. Sometimes we tell direction of a unknown place using a known place or not. Like if I ask you where is, earlier I was in Ashok Nagar, no, so I have that example in my head. If someone will ask where is Allen Ashok Nagar, so we'll say like where is Kasi Theatre is next to that. So what really we have done, I'm telling the location of an unknown place, Allen Ashok Nagar, using a known place which is Kasi Theatre. No? Okay. So same way, this vector A is something I know which way he is pointing along. So, and this 53 degrees is the angle made by OQ from a vector which we know which is A. So I can report this angle, which I call it as phi, to report the direction also or not. Correct? Maybe I can report this one also. Totally fine. But once I know this, obviously I can find the other one also. But this is like looking nice, so I will use this one to report the direction. So whatever we have done just now is triangle law with addition without knowing it. Okay. So main purpose here was to understand what really is the purpose of adding few vectors. Is to find one single vector that will bring same outcome as the vectors which are added. And never ever you will find someone adding velocity vector with force vector. It's like blasphemy, no? Whenever we add same things, no? So we'll be adding force vectors with force vectors only. So if I add A and B, which are force vectors, and we found out R, the sum of them, it means whether I apply A and B both, or if I apply R only, the outcome will be same. If A and B are the vectors through which we travel some length, like here A and B, so whether I do A and B both, or else I do the resultant OQ only, the outcome will be same. Clear now? Easy things only, or not?
Yes.
Okay, copy this all if you have to copy this thing. Once copying, tell me. See, so much time and done, and what we have done, man, nothing, no, till now, man. Like, literally nothing. That's why to do things properly, it takes time actually. Tell me something, any doubt? You want me to explain this thing? Right. No, Rama. So this week summer holidays will be over, man.
Sir, sir.
I should have started using it before only, man. Because if I am ahead of everyone in Chennai by one chapter also, then everyone will be ahead by at least 2,000-3,000 ranks by other people also. Friday, is it possible to keep class during 2:30 to 4? One day before, I will confirm also, because what happens, sometimes timetable changes a day before actually sometimes. So Thursday, I will tell you what timing a day before. If something you don't understand in online class, I will repeat everything back in offline class. That is not a problem. Main thing is that everyone should understand it properly. So if you have extra time on hand, that so these are simple things. Not like you cannot understand it online.
Sir, I have. So the magnitude of resultant vector will always be greater than the.
That depends. That we will see. That we will see. We have started how to find. Just I told you what you get on finding resultant. How to find, once I tell you, you will understand on your own. It can be less, it can be more. Like this example you see, A and B are in what directions opposite?
Opposite.
So resultant is 3, no? Less than both of them.
Yes.
Depends. Got the point? It depends, no? How they are given. Correct? So here you see they are in same direction. Resultant is bigger than each one.
Mhm. Okay.
Could
So
depend.
the angle between two
This
vectors.
will matter. Yeah. Once done copying, just tell me through this is like nice thing to run. None of the emoji is useful for class, man. The color also I can see the emoji. Once done copying, tell me. So in case if you have not copied, you do like this. I will understand not copied. Okay. I'm also over, no? We do one thing. So maybe we'll end the class here. I will share this thing. So what you will do? Suppose if you know how to find sum of vectors, in case if you know how to find component, then you start doing physics a chapter ahead of the class. Okay. So I will end the class here. The whole class will be from, okay, maybe I will tell one small thing. There's something called tail head arrangement. Here I can do this one. What it is, suppose if I have two bogies of a train, two engines of a train, maybe I'm using two engines to pull a single train. And this is the front, this is the back. This is the front, this is the back. Then how you will be connecting those two engines? Like case first or case second? First only, no?
Hmm.
Correct?
Hmm.
These are the two engines of a train. This is the front, this is the back, this is the front, this is the back. Thinking that engine can travel in not backward only, front direction only. So how you will be connecting those two engines like this? So suppose if I have one arrow of the vector, one time I saw something called, what is name, man, which lives like something like mice only. I forgot its name. And there, saw that thing in some forest rest house. There they were like rats, and they were going like a train, man. Like literally like train, and not like one, two, four, five of them like that, going around in some forest area it was. Forgot its name. So you see, this is the tail, this is the head, no? So one guy holding the tail of the previous one. This is the tail head. Tail head. This is called as, I am giving this graphic kind of example so that you will not forget what is tail head arrangement. So if I draw this arrow A of A and this arrow of B, you see how these arrows are. Wherever is the head of the arrow of A, there lies the tail of the next arrow B, no? Of B, correct? So wherever A terminates, there B starts. Such arrangement is called as tail-head arrangement. So in order to apply that triangle law of vector addition, we can apply it only when vectors are given to us in this tail-head arrangement. If not given to us in this arrangement, that is different thing. So what we do, we bring them in this arrangement by shifting one of the vector parallel to itself. Or maybe we will not use triangle law, maybe. It's not like only triangle law is going to be used to find sum of two vectors. It is one of the way by which we can find sum of the vectors. So if really I want to apply triangle law, then I have to bring the vectors in tail-head arrangement if they are not in that arrangement by shifting one of the vector parallel to itself. Okay. So if you have completed the basic math questions, don't waste more time, man. If you're able to solve good, not able to solve still good. Because if you have understood like slightly also in class things, that is enough for doing physics. I'm not telling physics, JEE advanced physics, I'm telling. I'm not telling like simple physics you can do, all physics you can do. Those are like math kind of questions. If you get it in one attempt, don't waste any time. You try to read vectors on your own, and then you try doing next chapter of physics on your own. Be ahead of the class by one chapter, always. Okay. Because my target is like everyone should get at least an 90, man. Then only it will feel good. Or relax that okay, man, at least everyone got an 90. So I have done my job. Okay. So it gives like satisfaction. I don't know. You will realize, but don't become teacher. Good only, but very hard work. After some years, it becomes boring also because same thing is to be taught again and again. Okay, then. So we'll end the class. I will share the recorded session. I will share the PDF also. And Friday, if I keep class, I will tell it before at least Thursday night, before 9 p.m. I will tell you. Okay, okay, and bye everyone. Thank you for coming in extra class. Bye.
Thank you, sir.
Anyone having doubts in the module, they can stay and they can ask the doubts if they have. If no doubts, then no problem. Any doubts in the module? Try the module. Okay. All right. During this time, try the module. Okay, then. Santhya and Bihan, Ashini, no doubt. No, Chaitanya, no doubt. No.
No, sir. Thank you, sir.
Okay. Right. Okay. I will end the class then. Tell me. And these doubts will go away. Man. Yeah, so they are displacement. Also.
So displacement also have since it's also a vector.
So no. When we have got 1D things, no?
Hmm.
Then we use science to tell direction.
Okay.
Suppose if I am doing 1D thing like throwing something in vertical direction,
Hmm.
then you will decide a sign convention of what positive.
Okay.
So that something travels down. I don't have to say so many things 5 meters downward and say minus.
So displacement is not a vector.
It is a vector quantity.
Okay.
Yeah. But when I have to tell direction of a vector in 1D, I use plus and minus to tell direction.
Okay. Oh.
Plus and minus are used for direct identities.
Okay. In 1D.
Yeah. Suppose something has to travel only along x-axis, then two choice only it can travel along plus x or minus. It's traveling along plus x, suppose with speed 2, I'll say plus 2 meters per second is the velocity. But if traveling with 3 speed but along minus 6, I'll say minus 3 meters per second is the velocity. Minus is a way to tell direction.
Okay.
You don't use minus, you tell root 3 along minus x axis. That much I have to say. Or you say minus 3 times.
Okay.
Do you understand how that is?
Yes, sir.
So don't miss any process.
Okay, sir.
Even though sometimes it might be difficult to understand, it will be. Because if anyone is taking things properly of JEE Advanced,